This video will teach you how to simplify complex fractions. All complex fractions are, you've got a big fraction, it's got a bunch of little fractions inside of it. So what we're going to do is we're going to combine what you've learned about how to add and subtract fractions, as well as how to multiply and divide them, and put them in a blender to solve these more complex fractions. Couple of ways that you can solve them. You can see the two methods listed out there at the top of the screen. The way that I'm going to do it is I'm going to look at what's in the numerator, simplify what I can there first, then look at the denominator, simplify what I can there second, and then once I have those two sets of fractions combined and whatever, I'm going to go ahead and divide them based on what we've learned within the last couple of days. So rather than trying to find a common denominator for everything, I'm going to find just common denominators in the numerator and denominator separately. So let's take a look at number one. Number one is the numerator 5 over x plus 4. The beauty of having only one fraction in your numerator is that you don't need to find an LCD. So this is good to go, which makes life simple, at least for the numerator. The denominator, however, we've got two fractions. There is no common denominator at this point. So what we need to find is the LCD. So if I look at my denominators, x plus 4 and x, well, they're not factorable, which is good because that'll kind of save us some time. But we need each of them. So we need an x and we need an x plus 4. So what I'm going to do is I'm going to work with the denominator here. So I'm going to leave the numerator alone, write the 5 over x plus 4. I'm going to put a bigger fraction bar so I know the difference between my little fraction and my big fraction. My denominator in the first problem here, I've got the 1 over x plus 4. Well, in order to have the LCD match, I need another x. So I'm going to have 1 over x plus 4 times x over x plus 2 over x times the x plus 4 that it's missing. So once I do that, again, in my top, nothing to do there. In my bottom, we're going to have, in the first clump, I'm going to have x over x times x plus 4 plus 2x plus 8 over x times x plus 4. And then once I do that, I can actually go ahead and then combine things here. So what I'll now have is 5 over x plus 4 all over, ends up going to crunch together and become 3x plus 8 over x times x plus 4. So that at least combines my fractions and my denominator together, but now what I need to do is simplify it from here. So what I can do to rewrite this problem, so remember, a big fraction bar is just a fancy way to say let's divide. So what this problem actually is 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. Now, as you've learned in previous lessons, if I'm going to divide two fractions, that becomes a multiplication problem. So what I'm going to do is I'm going to rewrite that. But remember, if I'm going to change it to multiplication, that means I need to flip the second fraction. Once I do that, now it's just a matter of, let's see what goes together. What can I cancel out? So I see an x plus 4 on top of each other. And that's pretty much it, which is going to leave me with a final answer of 5x over 3x plus 8. So again, this is kind of like with adding and subtracting or any of the other operations. It's a little tedious in that you do have to put a lot of different pieces together, but it's a lot of basic operations. It's just a matter of, again, one thing at a time, taking your time within finding common denominators, and then eventually it turns into stuff that you're a little bit more familiar with when it comes to multiplying and dividing. So it's just using really all of your operations in one big problem. Number two is the exact same idea. Now, the denominator is a little bit nicer because they're all numbers, so that's going to help. Let's go ahead and find the LCD of the numerator. So I have a 3 and a 6. Well, I can easily get from 3 to 6 by multiplying by 2. So my LCD for the top is going to be 6. In the bottom, I have 5 and 10. Well, again, 5 times 2 easily gets me to 10, so my common denominator is going to be 10. This is nice when your common denominator is exactly the same as one of your denominators because it'll be less for you to have to multiply. So let's go ahead and take care of the numerator. So I have x over 6. Since my common denominator matches, I don't have to multiply by anything. You could theoretically do 1 over 1, but that's kind of useless. My second fraction has a denominator of 3. In order to get a denominator of 6, I'm going to double it, multiply by 2. All over x over 5. Again, my LCD for the denominator has to be 10. So I'm going to multiply by 2 over 2. Minus 7 over 10. And again, my denominator was already 10, so that's covered. So we're going to simplify. And we'll get x over 6 minus 2x over 6. All over 2x over 10 minus 7 over 10. Which will then simplify into negative x over 6 all over 2x minus 7 over 10. So now, once I've simplified my numerator and denominator, made them one fraction in each part, now I'm going to go ahead and rewrite it so that I can actually finish up the solving process. So it'll be negative x over 6 divided by 2x minus 7 over 10, which will convert into a multiplication problem. So negative x over 6 times 10 over 2x minus 7. Now, there's not a whole lot we're going to be able to simplify here. The only thing we can really do is look at the 10 and the 6. We can divide a 2 out of each, make it 5 over 3. So I can rewrite this as negative 5x on top, 3 times 2x minus 7 on the bottom. And that's really as far as that problem is going to go. So, those are the first couple of examples there. Again, it's kind of the same process here. It's just, like I said, very lengthy, but that's kind of how you go about solving these here. So let's go ahead and look at the other two examples here on the next slide. So once again, we're going to go find some LCDs. So, LCD. Now, you'll notice the first fraction has a denominator of 3. Second problem here doesn't look like a fraction, but it still doesn't have a common denominator because technically it has a denominator of 1. That makes the LCD pretty easy, though. If you have something that has a denominator of 1 and a 3, it's just going to convert to 3. Same thing with the denominator here. I have 10, which is the same as 10 over 1, and 4 over x. Well, again, if I have to compare a denominator of 1 with a denominator of something else, your LCD is whatever that other thing is. In this case, it's x. So, let's go ahead and do the same process here. So, my numerator, first fraction stays alone. Second fraction, I'm going to multiply by 3 over 3. Denominator, I'm going to take the first fraction, multiply by x over x. Second fraction I can leave alone because my denominator already matches. So we start simplifying my numerator. I'm going to have x over 3 minus 18 over 3. All over 10x over x plus 4 over x. Simplifying my fractions, I'll have x minus 18 over 3. All over 10x plus 4 over x. Now all I have to do is convert that to a multiplication problem here so I can finish it up, factor out what I can, and solve. So I'll start here with writing it out so it has the division symbol. X minus 18 over 3 divided by 10x plus 4 over x. So again, we convert that to a multiplication problem. Change the sign. Flip that second fraction. So if we look at this here, it doesn't really look like there's much of anything to pull apart. So the 3 doesn't simplify with anything, same with the x. The only thing that if you really wanted to was you could pull a 2 out of the 10x plus 4 and simplify that down a bit, but honestly that doesn't really get you anywhere. So I'm just going to leave my final answer as x times x minus 18 over 3 times 10x plus 4. Again, you could take the 2 out of the 10x plus 4. It just doesn't cancel or do anything for any purpose, so I'm just going to leave it alone and call that my final answer. All right, last problem here is the same idea. We get a break with our numerator because it's only one fraction, so I don't have to do anything to it. That's fun. My denominator, we've got a denominator of x plus 1 and a denominator of x. The fact that I have two different denominators means my LCD needs both pieces. It needs the regular x and it needs the x plus 1. So we're going to rewrite this here. Top fraction is going to stay put. Bottom fraction, we need to multiply the first one by an x over x. The second one by an x plus 1 over an x plus 1. So my top is going to stay the same like I keep referencing. The bottom, I'll have 4x over x times x plus 1 plus 6x plus 6 over x times x plus 1. And we'll simplify from there. So I'll have 16 over x minus 2. All over, that'll be 10x plus 6 over x times x plus 1. So I'll rewrite this here as a division problem. And then we'll convert it to multiplication. Now again, not a whole lot you can do with this. The only thing you could do to simplify this just a little bit further. So kind of like the last problem. You have 10x plus 6. You could divide a 2 out of each. So what this can look like is, first fraction, we can't do anything. Second fraction, I can take a 2 out and be left with, let's see here, 5x plus 3. The reason why that you could technically do that, because that actually will reduce a little bit with that 16 up top. Because 16 over 2 would be 8 over 1, which would leave you with a final answer of 8x times x plus 1 over x minus 2 times 5x plus 3. So that's how you simplify complex fractions. Basically, you have to take all of your knowledge of how to add, subtract, multiply, divide, and it combines it into a blender, and this is when you use all 4 of them at once. So, again, tedious process, but if you understand how to add, subtract, multiply, divide, you can certainly tackle these. You just have to take your time with all the steps. And that's how you simplify complex fractions.